Smart India Hackathon 2022. Theme: MedTech, Biotech, Health Tech. This project belongs to India International School, Mansarovar, Jaipur. Student: BHAVYA KHURANA, Class 10th, Junior Category. Teacher Guide: Ms. Sonam Ghakar. The name of the project model is MedDiagnoseBot. The principles involved are AI, CV domain, teachable machine with Google platform, and deep learning. Let's have a look at the problem situation. The most common issue in most of the government hospital OPDs, outpatient departments. It has been seen a huge crowd of people waiting for their turns to be examined by the doctors for their disease and get the best treatment. But unfortunately, many don't get a chance to even get examined by the doctors due to huge number of available patients. Oftentimes, patients end up meeting wrong specialization after spending hours in huge lines because they are not aware that which specialization addresses their case the best. So, the solution to the problem is MedDiagnoseBot. Addressing the mentioned issue and to ease the burden on doctors and make the medical facilities and treatment available to all, I plan to design a machine that works on the principle of AI and CV domain. It works to see the visible symptoms of the patient, match it with the available set of fed-in data, and diagnose and tell the patient which doctor or medical faculty would be able to provide the best treatment according to the case of the disease. Also, it will lessen the workload of the doctors so that they can directly provide the prescription instead of spending much of time in understanding the case and disease of the patient. My model works on the teachable machine with Google platform. The platform provides with option to feed in data in the form of pictures. I'll be feeding pictures of various diseases, the physical appearances of the disease with proper tagging of different disease which can be diagnosed by the machine. Then the machine model will be trained with all the data and made ready to be implemented. Then the actual patient or actual disease will be shown to the machine and the machine will use computer vision to identify the disease and refer to the appropriate specialization to be cured. Let's begin. First step, collecting sample pictures of the diseases from Google and saving them to be fed to the machine for training the model. Sources is Google Images. Since this is a sample model, we have included only 4 diseases, namely acne, dry skin, ingrowing toenail, and psoriasis. Collecting the image and downloading from Google Images. Collecting and saving all the required pictures and giving them proper tags. Next step, feeding the information to the machine and training the model for its implementation. This is the demo of how the model was created. We have to go to the website teachablemachine.withgoogle.com and choose image project, standard image model, and then we have to rename the classes. We have used 4 diseases in this model, so we'll be naming them accordingly. The first class will be named acne, the second dry skin, third ingrowing toenail, and fourth psoriasis. These class names will be later on used by the model to detect and tell which disease is shown in the sample. After successfully renaming the classes, we have to upload the image samples. For uploading the image samples, we'll use the collected pictures. For acne, we'll upload the images. We have used 35 image samples. Next, for dry skin, we'll do the same. We'll upload the images. Choose the images which belong to dry skin. Since we have used CV domain in this project, so the images need to be clear so that they can be recognized by the machine. Following the similar process for ingrowing toenail, we have selected the pictures and uploaded 11 image samples for ingrowing toenail. For psoriasis also, we'll do the same process. Upload the images which belong to the category so that the machine works efficiently. After uploading all the image samples successfully, it's now the time to train the model. For it, reset the settings to default and train the model. The model will take several minutes to train the model, and this is a fast forward version of it. This model gets trained using the samples that we have uploaded, so we have to be very careful while uploading the samples. Mistakes are not to be committed while uploading the samples. Now the model is trained and we have to input the sample to check if the machine is working fine. We'll choose the input mode as file and choose the image. We have choose a random image of the disease so that we can detect if the machine is working well or not. This is a sample of ingrowing toenail image. And see, the model is working fine. It is detecting 99% according to the data fed to it that this sample belongs to ingrowing toenail. This is how the model works. The next step is to export the model for its implementation and use. You can type the given link on the browser to view the model that is demonstrated. Now the next step is to export the model. Now this platform provides us with variety of options in which we want to export the model. It shows us various code snippets to be used. The one demonstrated here is TensorFlow.js. It is code written in JavaScript and p5.js. We have also received one shareable link that can be used to be shared with several people and they can access the model. The model works in a similar way. We will choose the mode as file and then we can add the images, sample images, and the machine can detect which disease or which category the sample belongs to. And here also we are getting the same result, the images of ingrowing toenail. Looking at a different view to export the model, we can also export this model in offline view on the device. For this we have to download the model. It provides with a variety of model conversion types also, such as Keras, saved model. In TensorFlow Lite, it provides with model conversion types as floating point, quantized, edge TPU. It supports GitHub codes also, and it provides code snippets for Android and Coral also. So it's based on the applications we are going to use, and it's completely independent and we can choose as per our requirement. Now, what next can we expect? To what next level can it be extended? Let's see. Robotic surgery. Robotic surgery or robot assisted surgery allows doctors to perform many types of complex procedures with more precision, flexibility and control than is possible with conventional techniques. It can be given exponential progress by including the concepts of AI, CV and DS. The same model can be further elaborated with more advancements and progress and can do wonders in the field of robotic surgery with more amount of fed-in data, with more intelligence provided and all that. To the next level, implementation of robots to work in the medicine labs to discover new medicine solutions. And the aspects of AI are data science and deep learning. The robots can be used to find out new solutions, new drugs that can be used to cure diseases. Sometimes it's very risky for the lab technicians to deal with so many solutions to find a drug that suits a patient. So with proper data fed, all the data science, all the computer vision, all these aspects can be used to provide intelligence to the robots so that they can work in the laboratories for finding different drugs which can be very beneficial to the mankind. Scope for new advancements is always there in the implementations to take it to even next level. With this note, I end my presentation here and I hope the problem mentioned and the solution that is provided will be taken into consideration so that everyone can be benefited by that. Thank you.